Hello grade 12, today we'll be talking about trigonometry. If there's any topic that you'd like us to do, just write it on the comment section and we'll do it for you. Given cos 16 is equals to p, we need to determine the following without the use of a calculator. Number 1.1, we need to determine the value of sine 16. Wait a minute, why would we get cos 16 on our statement but be asked about sine 16 on our question? Is there an invisible relationship between sine and cos? I hear you cry. So that's the first correlation that this presentation will establish. But the second aim that this presentation will fulfill is how to work with grade 12 trigonometry double angles in cases where your grade 11 knowledge can cause you to break down during calculations. So to deal with the first objective, let's understand how a Cartesian plane works. So our Cartesian plane is made up of four main quadrants that are 90 degrees apart. So the first quadrant is understood to be a 0 plus theta. What that means is we are moving from 0 degrees and we are adding an unknown angle anti-clockwise. As we move our anti-clockwise direction, we will have 90 degrees plus. That is our second quadrant because we've moved past 90 degrees. And you can also call it at 180 degrees minus, all the way up to 360 degrees minus theta. And this means that we are a few degrees away from our 360 degrees revolution. So in all our quadrants, I'll make things a little bit exciting by putting right angled triangles with sides x, y, and r. So in this, x represents our adjacent side, y represents our opposite side, and r represents our hypotenuse side, which is the longest side of our right angled triangle. Well, it turns out that our trig ratios relate according to a right angle, and we use a mnemonic SOHCAHTOA to understand this relationship between our trig ratios. So sine will be opposite over hypotenuse, cos will be adjacent over hypotenuse, and tan will be opposite over adjacent. So according to this genius, our ratios are all positive in the first quadrant since x, y, and r are all positive. On our second quadrant, only sine will be positive because both cos and tan are composed of x in their ratio. And remember that x is negative in the second quadrant and in the third quadrant. And in the third quadrant, which is 180 degrees plus theta, as you now know it, only tan is positive in that quadrant. So what do we do with this information? A whole lot. You're probably looking at the right angled triangle, and we are not mentioning the most important thing about a right angled triangle. Guess what? I was reserving it for this moment. The theorem of Pythagoras, which states that the sum on the squares on the two sides of a right angled triangle is equals to the square on their hypotenuse. So on our question, cos 16 is equals to p, p has a denominator of 1. Yes, p is adjacent to our angle 16 and 1 is our hypotenuse. So if we are required to work out sine 16, we'll definitely need the opposite side y. But with the theorem of Pythagoras, it is easy to find this mysterious y. Well, it turns out that by simply substituting two sides, which is x and r, we can find the value of y as the square root of 1 minus p squared. Once we have the value of y, we can now walk on water because we can work out both sine 16 and tan 16. Remembering that sine theta is equals to opposite divided by hypotenuse, as you now know it. Therefore, sine 16 will be equals to square root of 1 minus p squared divided by 1. On our second question, we are compelled to remember our quadrants. 196 is 180 plus our angle, in which case our angle is 16. Simply put, 196 is equals to 180 plus 16. Therefore, we learned to turn 180 plus 16. This happens to be the quadrant where tan is positive. Note, 180 plus has no meaning, apart from reporting to us that we are working with the third quadrant. I will ignore it momentarily and write tan 16. Which in terms of our mnemonic TOA, opposite divided by hypotenuse equals square root of 1 minus p squared divided by p. You of course recognize that we've dealt with the first aim of our presentation. So let's go to the second part of our presentation where we work with the double angles. For cos 2 theta, we have 2 cos squared theta minus 1. The second identity, which means the same thing, is cos squared minus sine squared theta. Lastly, 1 minus 2 sine squared theta. When solving our problem, it is important to note that 328 is closer to 360 by 360 minus 32, as thus cos 328 is the same as cos 360 minus 32. Remembering that 360 minus is just a quadrant, it means nothing. It is telling us that cosine is positive in the fourth quadrant. Therefore, we ignore 360 minus and write 32. Now that the above information speaks of angle 16, we can argue that 16 and 32 relate when 2 is multiplied by 16. Therefore, cos 2 multiplied by 16 is the same as cos 32. Now, putting this requires us to use a double angle. And a double angle identity that we will use is 2 cos squared theta minus 1. And putting in our theta as 16, we have 2 cos squared 16 minus 1. And remember that cos 16 is equals to p. Therefore, putting p there will land us on 2p squared minus 1. Thank you.